The history of artificial intelligence is a fascinating story, a journey from science fiction concepts to the transformative technology that defines our world today. Our story begins in 1950, when the brilliant Alan Turing introduced what would become known as the Turing test. Then, in 1956, AI was officially born. At the now legendary Dartmouth workshop, a group of visionary scientists coined the term artificial intelligence. In 1966, with the creation of ELIZA showed that a machine could simulate human conversation, paving the way for the conversational AI we use every day. The periods from 1973 to 1987 are known as the AI winters. AI made a powerful comeback in 1997 when IBM's Deep Blue supercomputer defeated chess champion Garry Kasparov. The modern era of AI truly began in 2012 with the deep learning revolution. And that brings us to the modern AI era, from 2020 to 2023 and beyond. With the launch of models like GPT-3 and ChatGPT, AI became a mainstream phenomenon. Let's take a look at some of the key moments that shaped this incredible journey. Welcome, everyone. Take a look at this. The journey of artificial intelligence. It is a story far greater than most of us imagine. It's not just a recent tech trend, but a quest that stretches back for centuries. This is a tale of human ambition, our relentless drive to understand and replicate intelligence itself. It's a journey filled with incredible breakthroughs, but also devastating setbacks. Think about it, a continuous cycle of innovation, failure, and the ultimate push forward. We're going to dive into this fascinating history, exploring the pivotal moments that brought us to the technological revolution we're experiencing right now. So, where did it all start? The seeds of AI were planted long before computers became a household item. We're talking about the scientific groundwork, the very foundations of how we think about intelligence in machines. In 1943, two brilliant minds, Warren McCulloch and Walter Pitts, published a paper that would change everything. They created the first mathematical model for a neural network, a concept inspired by the human brain itself. This was a monumental step, the first real attempt to put a mathematical framework around something as complex as thought. Then, just a few years later in 1950, the brilliant Alan Turing, widely regarded as the father of theoretical computer science, dropped a bombshell. In his groundbreaking paper, he introduced what we now call the Turing test. It was a simple yet profound idea, a game designed to answer the question, can machines think? This wasn't just a thought experiment. It was a challenge that set the stage for all the AI research that would follow. This is it, the official beginning. The period between 1956 and 1974 is often called the golden era of AI. It was a time of boundless optimism where researchers truly believed they were on the verge of creating human-level intelligence. It all started in 1956 with the famous Dartmouth workshop. This wasn't just another conference. It was the birthplace of the field itself. It was here that computer scientist John McCarthy coined the term we all use today, artificial intelligence. Just a couple of years later, in 1958, McCarthy gave the field another essential tool when he developed the programming language Lisp. This language was specifically designed for symbolic reasoning and would go on to be the standard for AI research for decades. Then in 1966, we saw a truly remarkable moment with the creation of the ELIZA chatbot. Created by Joseph Weizenbaum, ELIZA was one of the first programs to show just how human-like a computer could seem in a conversation. It was a powerful and, at times, unsettling demonstration of how people could form emotional connections with a machine, even though the program was relatively simple. During this incredible time, researchers were so confident that they were making bold predictions. Many believed that machines with human-level intelligence were just a few years away. But then, reality set in. The ambitious promises of human-level intelligence didn't materialize. This period from 1974 to 1980 is known as the first AI winter. It's a term that perfectly captures the mood, a time when funding and enthusiasm for AI research froze over. As one quote from an AI pioneer perfectly summarizes, I believed we were 10 years away from human-level AI in the 1960s. 50 years later, it's still 10 years away. This quote reflects the bitter disappointment that took hold. It was put on halt because of the limitations of the technology. First, the models themselves couldn't scale. The simple programs that worked on toy problems fell apart when faced with the complexity of real-world data. Second, the computational power needed simply wasn't there. Early computers were incredibly slow and had limited memory, which made any significant AI development practically impossible. And finally, a massive roadblock emerged: common sense reasoning. Researchers found it was incredibly difficult to program a machine to understand the basic intuitive knowledge that humans possess naturally. It was a problem they hadn't even anticipated. After the long, cold winter, AI came roaring back to life. The key to this revival wasn't trying to create a general human-like intelligence, but rather a more practical, commercially viable approach. This was the era of expert systems. These systems were designed to solve complex, real-world problems by using a set of rules crafted by human experts. Instead of thinking, they reasoned like a human expert would within a very specific, narrow domain. The game changer was a system called R1, later renamed XCon. Developed at Carnegie Mellon and used by the Digital Equipment Corporation, this system was designed to automatically configure complex computer systems for customers, and it was a massive success. XCon saved the company millions of dollars and, more importantly, it proved that AI had real commercial value. This success triggered a huge boom in expert systems and sent a clear signal to the industry. AI was no longer just a futuristic dream, it was a powerful business tool. The boom didn't last. The promise of expert systems, while initially profitable, turned out to be overhyped. This led to another period of disappointment and skepticism, the second AI winter, which lasted from 1987 to 1993. The reason for this halt is because of companies had been sold on a dream that the expert systems couldn't fully deliver. There were three major problems. First, these systems were incredibly expensive to maintain. They were built on a rigid set of rules, and as soon as the knowledge in their domain changed, which it always does, the entire system became outdated and required a costly overhaul. Second, they had major scalability issues. While an expert system could master a narrow task, like configuring computers, it couldn't easily be adapted to a broader or more complex problem. They were islands of expertise, not versatile tools. As these limitations became clear, funding plummeted once again. But even as the public enthusiasm waned, a quiet revolution was taking place in the background. Researchers continued to work on different approaches, specifically in neural networks and machine learning, laying the crucial groundwork for the massive AI boom that was still to come. After the second AI winter, the field didn't just warm up, it was reborn. The focus shifted away from those rigid, rule-based systems and towards something far more powerful, which is machine learning. This new approach was all about using massive amounts of data and powerful algorithms to teach a machine how to learn on its own. And the world began to take notice. In 1997, a major milestone was reached when IBM's Deep Blue, a chess-playing supercomputer, defeated world champion Garry Kasparov. This wasn't just a game. It was a powerful demonstration that a machine could outthink the greatest human mind in a complex strategic challenge. Then, in 2002, AI came into our homes in a way no one had expected with the Roomba. This autonomous robotic vacuum cleaner made AI tangible for everyday consumers, showing that a robot could perform a useful task without direct human control. Finally, in 2011, IBM once again captivated the world with Watson, a system that defeated the greatest champions on the game show Jeopardy! This was a monumental breakthrough because it showed that AI could not only process facts, but also understand the nuances, puns, and complexities of natural human language. And this brings us to the present day, the era of breakthroughs that have captured the world's attention. We're now in the age of modern AI, fueled by deep learning. It all began in 2012 with AlexNet. This wasn't just another computer vision model, it was a watershed moment. Its breakthrough performance in an image recognition competition proved the power of convolutional neural networks and the deep learning approach. This single event ignited the deep learning revolution, leading to its widespread adoption across the field. Then, in 2016, humanity witnessed a new kind of intelligence. Google's AlphaGo defeated the world champion of Go, Lee Sedol. This was a monumental feat, as Go is a game of intuition and strategy with more possible moves than there are atoms in the universe. AlphaGo's victory showed that AI could not only calculate, but also develop an almost human-like intuition. Just a year later, in 2017, a paper titled "Attention is All You Need" introduced the transformer architecture. This revolutionary design allowed models to process vast amounts of data in parallel, fundamentally changing the way we handle language and paving the way for the large language models of today. Finally, we arrive at 2020 and 2022 with the release of GPT-3 and ChatGPT. These models, with billions of parameters, ignited a global conversation about generative AI and brought this technology into the mainstream. Suddenly, millions of people were interacting with AI daily, using it to write essays, generate code, and create art, ushering in the era of AI-powered creativity and productivity that we're still just beginning to explore. And so we arrive at the present day. AI is no longer a concept from science fiction. It is a fundamental part of our world. It has evolved into a transformative technology that is reshaping nearly every industry imaginable. Take a look at transportation, where self-driving cars promise a safer, more efficient future, and AI systems are already optimizing traffic flow and predicting when a train or a plane needs maintenance. In healthcare, AI is revolutionizing medicine by accelerating drug discovery, helping doctors with more accurate disease diagnoses, and even creating personalized treatment plans tailored to a patient's unique genetic makeup. The creative industries are being redefined. AI is now assisting with music composition, helping to generate new forms of digital art, and even writing content to help us create faster and more efficiently. In finance, it's working behind the scenes, using complex algorithms to detect fraud in real time, execute high-speed trades, and provide you with personalized banking experiences. And in our daily lives, AI is everywhere. From the voice assistant in your pocket to the smart home devices that control your lights and the recommendation systems that suggest what to watch next. But as AI becomes more and more capable, the journey continues. We are now grappling with a new set of critical questions about ethics, regulation, and what the future relationship between humans and this increasingly powerful technology will truly look like.